Well, welcome to ElmLive for November 26th, 2016. So today we're going to be hopefully finishing up this destructible board game concept that we started 2 days ago. So this is the third day working on this. So to recap, we have this board game where we can move pieces around, and on each of the pieces is this little Tetris shape, and when you move a piece, the tiles on the board are pulled along with the piece that you move, and the shape of that section of the board that moves matches the Tetris shape that's on the piece. So we have all that working, but it's kind of confusing about what's going on if you're actually moving the pieces around. So what I wanted to do tonight is add some animations so that when you move a piece, the tiles that are moving actually kind of lift off the page and animate over to their final spot so you can tell more clearly what's going on. So that's what I want to work towards right now. So I have been thinking a little bit about how to model this. So the idea is, or the way this is set up now, is everything is based on this make move function in our board module. And this takes two positions and the board, and then it tries to move a piece from the initial position to the final position. So in order to animate this, we're going to need to first of all know what to animate. And I also was thinking that I don't really want this board package to have to deal with animation, kind of like the timing and all the update loops related to animation. I think really are just part of our main module and shouldn't be part of the board, which is kind of like the logic of the game. So I was thinking that in order for our main module to have enough information to do this, that would mean that whenever we make a move, we want to get back the new board, but then also some additional information that will allow us to display the animation. And I think inside of this function, we potentially have all that information available. We might need to change this Terraform board function also, because there's kind of a lot of intermediate data in here that is potentially useful to us. So I think, let's see, what we're going to want for the board is we're going to want to get back not only the final board state, and let's actually put this in a record because this might get a little confusing. We're going to get the new board state, which is a board. And then what I also want to return back is kind of a board without the pieces that are moving. And then we'll have another set of information that contains just the things that are moving. And let's see, what is the best way to do this? So let's start out by only, let's leave the moving pieces out for the moment, no pun intended there. And we'll return our new board and our partial board. That's not the greatest name, but the idea here is that this is going to be kind of everything except the pieces that moved in this movement. And let's see, I have extra commas in there. Okay, and then we need to change the return type of this. So in the case that there's not a valid move, we are going to have the new board and the partial board. Actually, let's just return nothing in this case, because we'll want to know if we try to make an invalid move. We don't actually want to do an animation for that. So let's make this whole thing be a maybe then. And we'll return nothing if it's not a valid move that we've been asked to make. And if it is a valid move, then we will return a just, and then inside of here we'll have the new board, which will equal this thing that we were originally returning. And then we also need our partial board. And what's going to go in here? We want our initial board, but we want the pieces to have the moving piece removed from it. So this will be board.pieces with the moving piece removed. And then we're also going to have the tiles. And from that, I think we're going to need more information coming out of this Terraform board part. So let's see. In this case, then, Terraform board, we're also going to have it return some partial tiles. And let's see. Comment that out for a moment. So Terraform board currently returns the new resulting tiles, but I also want it to return the partial tiles, which we have calculated here. It's the tiles with the tops pulled off that are getting moved to the other part. So this with tops removed dictionary is the second thing we want to return. And then that means here we're going to have new tiles and partial tiles coming out of there. And in the case that we don't have a terraforming piece moving, the partial tiles are just going to be all the tiles. Okay, and then here in our partial board, we're going to have the partial tiles as well. Okay, so I think we've changed everything we need for the moment in our board module. And then in main, we should have some errors. Probably in our update function. Yep. All right. So here when we call make move, we are going to have some other things to do. So let's pull this out into a top level function so we have some more space. And we're never going to do any commands. So let's just take the model part and put it in a new function. We'll call update move. And what all do we need? Update move. It's going to equal this. We're going to need for this the starting model. And we're going to need the selected tile and the clicked tile. So we'll have from and to. So the position is going to be the to, and the selected is the from. So here we're going to pass model, and we're also going to pass the from, which is the selected tile, and the to, which is the position that we just clicked. Okay. And then here, let's add our type signature here. This is going to take a model and a board position and another board position and give back a new model. And that's going to fail because here's where our type signature is wrong. This make move, we change the return type. Okay. And I'm actually realizing that we really only need to have this take a board instead. And we can pull some of this code out. Specifically, all this code related to resetting the selected tile, that can stay out here. And then the board, we can actually maybe .map with update move. And then we'll shift these parameters around so that we can curry this better. This will be the board. Okay. So I think this will work out a bit nicer. We'll take the board and then we'll maybe .map it with our update move function. This means resetting the selected tile stays here in the update function, which I think makes more sense. And also it means we don't have to worry, we don't have to deal with the fact that model.board is a maybe inside of this function, which is also nice. So we're just going to have board piped to this function. And this is where the type is different now. Okay, so let's set up a let block, and we're going to be destructuring the record. We'll have new board and partial board. And those are both going to come out of board.makeMove with the board. And then here, we are going to return the new board. And let's see, did I spell something wrong? The function results in a maybe. Okay. So in this case, okay. Actually, I'm realizing now we do need to take the model because we want this function to update our model to contain the information needed for the animation. So the refactoring I just did needs to be undone, although this one part that I did like about this of having the selected tile, let's see. I think we can maybe kind of get the best of both worlds. We'll have this take a board and return a new model. That doesn't really help. Alright, I guess we do need to have this take the whole model. But I would like to leave this resetting of the selected tile as a separate step. So let's take the model. We will pipe it through update move, and then we will pipe it into a function which will reset selected tile to nothing. Alright, and then here, we're going to let's see. First model.board is a maybe. So we'll need to maybe.map this. Then board.makeMove from to, then this whole thing is going to be a maybe. This we'll call that result, and then we'll destructure it here. If we have a just, and if we have nothing, we are simply going to return the starting model. And if we get all this new stuff, then for the moment, we're going to take model and replace the board with the new board. All right, so what's wrong with the types here? So board.makeMove returns a maybe record when given a board, and model.board is a maybe board. This should be and then. That's the problem. And in this case, what is it telling us? The first branch has a type of selected tile, maybe board position. We need to put a just in here, because the board field in our model is a maybe board. Okay, so I think that has been refactored. Let's refresh and make sure everything works properly. Cool. Okay, looks like everything still works. So now we can do the real work of taking this new information, this partial board that we have exposed through the board module, and we want to do something with this in our model so that we can show an animation. So we'll need a bit of infrastructure set up to do an animation. We are going to need the current time stored in our model. We're also going to need animation, which will be a maybe, because we won't always have one, and if we do have one, we're going to have, I guess, the start time of the animation, and then we'll also need, in our case, the partial board that we want to show during that animation, and then also we're going to need information about the things that are actually moving and where they're moving from and to, but we'll get to that in a minute. So I just want to get this set up to kind of have an intermediate state, and then we'll add some pieces to that in a minute. So now we need to update our initial model to have all this data. I'll just set now to be 0 to start with, and the animation will be nothing to start with. Then, all right, our update function has some problems. Because in our second branch, whenever we create a new game, we decided earlier to reset everything. So in that case, actually the now should not reset. We'll keep that as model.now. And animation we will reset when we start a new game. Alright, that looks good. And okay, everything else is fine, because we just added some new data. So then we're also going to need to add a new message. So I usually call it tick. And we'll use the animation frame library to generate that message. And I think we'll need to install that package. Yep. Alright, so let's kill Elm Reactor temporarily. Elm package install, ElmLang/animation frame. And start up Elm Reactor again. Okay. Then, here in our subscriptions, we will subscribe to the animation frame subscription, but just so that we don't have poor performance, we'll only do that when there's actually an animation in progress. So we'll say model if model.animation is equal to nothing, then we will have no subscriptions. Otherwise, we will subscribe to animation frame.times with the tick message. Okay. And then we should need to handle that tick message too. Yep. Okay. So let's handle the tick message. And when we get that, then we will just update our model to replace now with the new time. And we'll have no command. Okay. Great. So I guess our next step is, let's see. I guess this is kind of interesting because we won't know the current timestamp when we actually make the move. So it actually, in this case, might be better to have this represent, rather than the actual timestamp, just kind of add to it every time we get a new frame with the deltas. I think that's going to turn out to be better, because otherwise we would need to store our start time, but we don't actually know when it's advancing and when it isn't. So yeah, I think we're actually going to need to track the diffs, which means in our tick here, we are going to add the new delta to the now time in our model. And that also means when we reset, we can just reset that to 0. That should be totally safe. Okay. So now, our other part here is when we do an update and we get a partial board state back along with our new board, we're going to set an animation in here. And the starting time of the animation is going to be model.now. And what else? Then the board in the animation is going to be the partial board. Okay. And then our final step is, I guess we're going to need to refactor this a little bit. So we have render tile, and here we have render board. So let's pull this all out into a function. Let's see, let's take this part, and we're going to render board with model.board in that case. Let's define that here. And then these definitions in our let block can come out of here and be put into our render board function. also need to define board there. And let's see, we also, I guess, need the model. Is that the only thing we need? This can just be model.board. Okay. I'll pass the entire model to that. That actually doesn't seem right. I guess we need to pass two things, the board and the selected tile. Because the whole point of pulling this out is that we want to be able to render different boards at our choosing. Alright, so this will be model.board and model.selectedTile. Okay. And that's why it's just board, because we destructured it out of the maybe. Okay. Cool. So, here's what we want to do differently. We actually want to check and see if there's an animation. And if there is, then we will handle that first. Let's see, so if there's nothing at all, we'll do that. If there is no animation and a board, we'll do that. And if there is an animation, let's see, what was in our animation? The start time and the board. And then we don't care what the model.board is at all. So if we have an animation in progress, then we are going to render the partial board instead, and we don't need the selected tile. That can just always be nothing when we're rendering an animation. Okay. Great. So let's try this out. What I think we should see happen is, as soon as I click to move this, then the tiles that are moving and the piece that's moving should just disappear. And our Explore History counter in the bottom right in the debugger should just start counting up as well. Okay. Cool. It looks like both of those things are happening. So our next step is we need to track the animation and mark it and clear it out, I guess, once it has finished. So we can do that in our tick, and we will, let's say, check for animation end. And we'll make that a new function, which is going to take a model and give back a new model. And let's see. So we are going to say, I guess let's just define this at the top. Animation duration is going to equal, I guess let's say 1,000 milliseconds, 1 second animations. Let's start with that. So we're going to say if model.now is greater than or equal to the start time of the animation. Okay, so we're going to have to destructure the animation. Case model.animation of, and if it's nothing, we're just returning the model right away. And if it's just start time, comma, whatever, we don't even care about the rest of the data in there. Then we'll do this check. We'll say if model.now is greater than or equal to start time plus the animation duration, then we're done. We're going to return model with animation reset to nothing. Otherwise, we're going to just let it continue. And animation duration is a time value. Okay. So, now if we try this again, as soon as I move this piece, it should hide the things that eventually we'll have moving. And then after 1 second, it should end the animation and we should see the final state, and the frame counter in our debugger should also stop. Great. So it looks like both those things happened as well. Okay, so that's all looking pretty good. I'm happy with kind of the architecture setup for the animations here. Let's see, let's add a type annotation to our render board function. So that's taking a board and a maybe position and returning an SVG, board.position. And okay, I guess apparently it returns a list of SVG. Okay, there we go. So what's next? So now we want to use that start time and kind of interpolate a position for things that are moving. So we're going to need some information about what's moving. And that's going to need to come from the board. And in particular, it's going to need to start coming from this terraform board for the tiles, but also, I guess, just for the piece that's moving, we should have all that information right here. So let's add this. So we're going to have moving pieces, which is going to be a list, and that'll contain a piece. I guess it's also going to need a player. So it'll have the player who owns the piece, the type of piece. It's going to have the from position. So that'll be a position, and it'll have the ending position. So this will just be a list of all the pieces that are moving. So let's get that hooked up, and then once we have that working and in place, it should be relatively easy to add the same kind of thing for the moving tiles as well. So now the compiler is telling us that we need to actually return this data. So that's going to need to be added here. And we're only set up to move one piece at a time, so this should be relatively easy. We'll just return a list with a single element in it, which will be the player. Where do we get the player information? Oh, I guess that's what we're calling piece here. Okay, so let's stick this into a tuple. It's a little bit confusing, but this thing is actually a tuple right here that has both the player and the piece type. So we'll have the piece, and we'll have the from position and the to position. Okay, great, and that type checks. So all we need to do now is update our update function. So this update move function that we just wrote a little while ago, here's where it gets back the information from the make move function. And now we need to also pull out the moving pieces, And I think we just want to stick that into this animation data as well. So let's go up, let's go up and change the type here. So then this will also contain a list of all those things that we just mentioned, board.player, board.piece, and also a board.position, and another board.position. Let's see, I want to split that onto separate lines. Is it not going to let me? No, I guess Elm format's not going to let me do that right now. Alright, so we have a ton of data in our animation field right now. Let's see, we should have some compile errors. Yes, okay. So here when we check for animation end, we don't care about the moving pieces. And where else do we have a problem? Oh yeah, here. Moving pieces. So now we have those, and we're going to want to render those on top of this board that we're placing here. So let's stick this into a group, and then on top of the rendered board, we will, I guess, render our pieces. So, how do we want to do this? I guess we'll take moving pieces, and we will list.map that, and for each one, we are going to get the player and the piece, and we have that here. So let's take this whole chunk of code that renders that and pull that out into a top-level function. Let's see if that lines up properly. Okay. So we'll have render piece, which will take a player and a piece. Render piece takes a board.player and a board.piece and gives back an SVG. Player and piece equals, and then we have all that. And what else is wrong here? Ah, okay, I have a typo. Let's comment that out for a moment. And let's see, there's a couple things referenced in here. So one thing is this. So rather than passing selected tile in, what I'd like to do is just pass a boolean is selected. And that'll go here. And then when we call render piece down below, we will pass that in. And what else? Oh yeah, and I just want to pass this message in as well. We're going to have our onClick as a message. And then we can just pass that in, and then we also don't need to pass in the position. So here, we'll stick that. Okay, so now we have this reusable render piece function. Let's see, so now, let's see if we can use it. So we're going to get the player and the piece in a tuple, and we're also getting from our moving pieces list the from position and the to position. Then we want to call render piece, and we've got to pass it a few things. First of all, we need to pass it this message. So let's actually make this into a maybe message, so that we aren't forced to pass it all the time. I'll say case on click of, and if we get nothing, we will return nothing or no list, and if we get just handler, then we will return a list with the handler in it. Okay, and that means down here we can pass nothing, because we don't want this animated piece to be clickable while it's moving. Then we're going to pass false next, because we don't want it to appear selected. Then we need the player and the piece. And then here I think we just need to put this in a group. Let's see. And we do not need to put this one in a group. But the board is in a group. Okay. Okay. And then what we haven't done yet is apply the from and to position. So that'll be the final step. So let's just see if this is working. So right now, we should see the piece that's supposed to be animating appear somewhere. I think it'll probably appear like in the very center. Oh no, it's appearing up in the top left corner for just a moment. And if I move this one, it appears in the top left. Okay. So what we want to do is translate it to a position that we're going to interpolate by using the current time to interpolate between the from and to position. So let's write the code for that. So we're going to have our percentage, I like to call it when I'm doing this. We're going to take now, a model.now, subtract the start time of the animation, which we are destructuring here, and divide it by the animation duration. And then we also want to clamp it. So we want the max of 0 in that, and we want the min of 1 in that. So we'll clamp it to the range of 0 and 1. Then we're going to have our x, which is going to be interpolated between the from and to x value. So I guess we can just write a little helper function to interpolate. There's probably such a function defined in a module somewhere, but I don't know what it is. So we're going to interpolate between tuple.first of the, actually we can just destructure these right here. This will be x1, y1, and 2 will be x2, y2. So we're going to interpolate between x1 and x2 with our percentage. And y is going to interpolate between y1 and y2 with our percentage. And we can write this interpolate function, ab percentage, And I guess we don't even need that defined in here because we have access to P directly. So this is going to be B minus A plus P times B minus A. Okay. And now, what all is going on here? These floats, the board positions are integers, not floats, so we need to convert these before we multiply or do anything crazy. So we will 2float here, and we will also 2float here. All right. So let's see. So now that we've calculated x and y, we actually need to translate this. So let's put this in a group, and we will have svg attributes.transform. I think we have some code up here that does that. Column and row, well, sort of. I guess we're going to need both of these things combined. Yeah, okay. Let's see. So here is our transform, and we're going to translate by the x amount, and then we'll do the same thing for the y amount. And what else is wrong here? We don't need that list. And this can go in a list as the children. Okay. So, let's see how we did here. We might see this piece animate if we did things correctly. Well, it's moving in the right direction. It's just offset by an interesting amount. It's always, let's see, it's down and to the right too far. Yeah, we're off by 1 on this somehow. That's odd. Let's see, if we just subtract 1, is that going to work? It seems odd. I would like to know why. Yeah, interestingly, that is fixing it, but I'm not sure why we need that off by 1 in there. However, it is working, so that's good. Alright, so given it's late on a Saturday night, I am not going to investigate this at the moment. We've got kind of some crazy code in here that needs refactoring, so maybe someday on a future Sunday ElmLive after Codevember is over, we can take a look at cleaning up this code and also understanding why we need this -1 in here. But for now, let's move on to our last step, which is going to be to make the red and yellow tiles animate along with the piece. So, let's see, I guess I should commit at this point. So let's see, we exposed some more information from Terraform board. We also exposed that out through make-move and some other additional information through make-move. Then we, what did we do here? This is still part of make-move. Then we added some animation data to our top-level model. Then we updated our update function in main. Then we refactored and rewrote a bunch of stuff in our view function in main so that we had a reusable render piece function that we could use to render our animation. And then we subscribed to the animation frame ticks while there's an animation active. And that's it. Alright, so this is animate moving pieces. Oops, I made some typos there. Animate moving pieces. I guess that's kind of redundant. Hey, Dragon Physics. Elm is a pure functional language that compiles to JavaScript, so it's used for front-end web development. I use it full-time at the company I work for, No Red Ink, for all of our new front-end code. But this month I've been doing a bunch of streaming every day to try doing some more like graphics-related stuff with it, which is not super common right now, but has been fun to experiment with. So this board game that we have up here is all done with SVG. Yes, Dragon Physics, is that not how you pronounce it? Dragonfly Zex? Okay, so what we just did was make it so that these pieces animate from their starting position to their ending position. And what we want to do next is make it so that the red and yellow tiles that are also moving around animate in the same way. The first one that's ever pronounced Dragon Physics right. I just kind of read the letters and said it out loud. I guess I had phonics when I was in middle school, so it paid off. Okay, so where we're going to start is this terraform board function needs to give us some more information about the tiles that are moving. So we've already modified it. It gives us two things. It gives us the new board state, and then it gives us some extra helpful information for the animation, which is the partial board that contains everything that's not moving. And then I guess we're also going to need it to give us a list of the tiles that are moving. So we'll have a tile, and we'll have the from position in that case, and the to position. Oops, if I can spell position wrong. I can pronounce words, but I can't say a word and type it. Okay, so now we have a ton of compile errors, or I guess just one, but we need to fix it by adding more information to here. So I'll just fill in a list, an empty list for the moment. But what we're going to need to do is calculate the list of all the tiles that are being moved. And, conveniently, we have exactly that list, which is code we wrote yesterday when we were writing this whole terraform function. So we have this intermediate data structure that actually has everything we need. We just need to map through it and rip out this color, which we don't need. Or do we need it? The color should be in the tile, right? Oh, no. I'm forgetting what that data actually means. In this list, this is the from position, the tile that's changing. This is the new state of that tile that is being changed. And then this is the color that's flying around. So actually, I think we don't need complete tiles. All we need here is the color that's going to fly around. Okay, so in any case, we can actually use this to produce the thing that we want. And we're just going to have to filter out the ones that don't have any colors. And keep those, and then kind of transform the tuple. Did I get any other viewers? I had a couple people tune in briefly this evening. I've been doing a lot of streams this week, so I think people are getting tired of watching it live. And this is not the time I normally stream at, especially on the weekend, so I just kind of announced it last minute on Twitter for today. My regular stream is Sundays at 11:30 Pacific time in the morning. So I have the most people watch then. I've been doing that for several months, and I've just been doing short streams every day for the month of November. Okay, so let's fill this out. We're going to take our movements list, and we're going to list dot filter map, which means we're going to give it a function that returns a maybe, and it's going to take out all the ones that are nothing values. And in here, we are going to get all of this stuff: the from position, the tile that we don't care about, the color, and the to position. So that's from, the tile, the color, and the to. And then this color is a maybe value, so we'll do a case on that. And if we get nothing, we will return nothing for this whole return value, and then that'll get filtered out by the filter map. And if we get a color value, then we're going to return a tuple that has the new structure that we want, which is the color value, the from, and the to. Oh, and we need to put this in a just. Okay, cool. So that all type checks. Oh no, it shouldn't. Well, this function type checks, but this function where we call it does not. So here we'll have moving tiles, and then we also want to return that out as a return value of make move. So this is going to be a list of color, position, position. And we'll pull this out here, and then when we create our record, we'll just stick it in. Moving tiles equals moving tiles. Okay. And here, if there's no valid, or if we're not terraforming the board, then we'll have no moving tiles. Okay, no issues. So this module is done for the moment. Let's switch back to our main module. And this type checks because all we did was add a new field to the record that's returned by make move. See you, Dragon Physics. Thanks for stopping by. Okay, so make move here. We can also now pull out the moving tiles. And when we have that, we're also going to stick that into our animation data. I guess I kind of have a mishmash of using tuples, and then we convert it to a record, and then we're converting it back to a tuple. We could probably clean that up quite a bit, but I'll save that for a future episode. Let's see, so our animation data here is going to be a list of color, board.position, board.position. And let's see. Oh, cannot find type color. Okay, great. We have to import it. Import color, exposing color. Okay. And then here, moving tiles. Okay, so that's all good. Then, when we are destructuring here, we'll pull this out as well. Moving tiles. And where else is our problem? Ah, yes, here when we're checking if the animation is ended, we'll just ignore it there. And let's see, moving tiles. Okay, so we want to render all the moving tiles, and we want to do that underneath the moving pieces. And this is basically going to be the same as the moving pieces, just with a different rendering. And we can probably extract some stuff. Yeah, so P here depends only on the model.now and the start time, which are both defined all the way up here. So we can actually kind of refactor this a bit. Pull P up here. Also, this interpolate function only depends on P, so we can also put it up at this level. And then our X and Y are specific to inside of here. Okay. Great. Actually, I want to try doing a little bit of a refactoring here. We'll call like a place function, and this will take an SVG and a from and a to, and that'll do most of this, like the transformation. So we'll call this x1, y1, and the 2 is x2, y2. And then this is all the SVG. And then this rendering logic we can reuse, or this positioning logic we can reuse. So then this all becomes simply place. And we can rename this to be from to. And actually, let's reorder these arguments a little bit. So in place, the SVG argument comes last. Okay, great. So this is a much nicer little piece of code. Oh yeah, and I copied it earlier. Okay, so those two are supposed to be the same. Okay, so this is a much nicer little piece of code to duplicate, and now all we have to do is change this to render our tile instead. And in fact, here we are getting a color rather than a piece now. So moving tiles, and then all we need to do is render a square of that color. And I guess here's the code for that. We could maybe extract a function, but I feel like a render tile function should be this whole chunk. And all we're really rendering is the color. So, I don't know, I'm not sure how I feel about extracting a function. I kind of would like to, but I don't see the clear case for reuse right now. So I'm just going to copy this down. So instead of render piece, here we are rendering a rectangle with the color. Okay. It feels like we haven't done the hard work yet, but I think it might be ready to go. So let me restart Elm Reactor, refresh our page, and try this out. Hey, great. that actually worked. Yeah, that is great. Perfect. So, okay, so two little finishing touches I'd like to try to do, if we can do this quickly. I'd like to have, let's see, I'd like to have, well, first we should have some easing on this animation, so it doesn't just start and stop statically. Then I'd also like to add a shadow underneath the moving pieces. I'm not actually sure how to do that in SVG. Let's look that up real quick. SVG drop shadows. Okay, we have to define a filter to do that. And I guess, okay, so here we can add a box shadow style. Let's try adding that to the tiles. SVG, actually, there isn't a style thing in SVG attributes, but we can use HTML attributes.style and try passing a box shadow. And what did the values look like for that? Let's just try this one. Okay, let's see how that looks. I don't really see anything on there. Let's see. Can we actually add a box shadow? -5 pixels, -5 pixels, 5 pixels, and like a black color. Yeah, I don't really see that doing anything. Oops. And here's an example using the drop shadow. Oh, there we go. Let's see, are they doing the same thing with, yeah, using a blur filter? Okay. Well, that seems like a lot of work for tonight, so let's pass on the shadows for the moment. But I would like to add interpolation. So we will use our standard package for this, the easing functions. And let's see, so easing is just a function that takes a float and gives a float back. We want to do like in-out quad maybe, something like that. In any case, let's install this package. And start up ElmReactor again. And then we will import ease. And then here, when we calculate our percentage, once we have that value, we're just going to pass it to our easing function, ease.inoutQuad. Okay, and that should set the easing. Yeah, cool. That looks pretty good. let's see, so what else? The other thing I wanted to do was have these pieces move kind of along an arc. So I'm not sure we'll actually be able to do that quickly. It might take more math than I am ready to do tonight, but let's give it a quick try. So to do that, all we're going to need to change is this interpolation function. Is that true? No, I guess both the x and the y are going to be required, so we'll have to interpolate them together. So we'll kind of have to change this. So let's see. So let's think this through and see if it's going to be easy enough to do tonight. The idea is we have a starting point and an ending point. Rather than making a straight line along those, I'd like to try to calculate an arc that goes along. And how are we going to do this? Basically, we want to create like a parametric function in terms of t. So actually, let's see. I should know this off the top of my head, but circle... Oh, duh, this just uses sine and cosine, right? Parametric equation. And yeah, x is just cosine of t, y is the sine of t. Okay. So our equation that we ultimately want is the actual x is going to be the sine, or the cosine of p. Y is going to equal the sine of p. But then we also need to find the x and y, like the center of the circle. So this is going to be the center x plus that, and the center y plus the sine. And then we also are going to need to find the P0, and P0 is going to be the point at which let's see, P0 is going to be the point at which x equals x1. So we'll have x1 equals cx plus the cosine of P0. And I guess we'll want to solve P0 for that. So P0 is going to equal the arc cosine of cx minus x1. So that was derived from this. And let's see. I guess we're also going to need to know the ending position. Let's see, this is not quite going to work right. Let's see. Well, maybe it will. The other issue was we want to calculate cx and cy, and I guess the easiest way is to just place the center at the halfway point, and then we'll have the steepest arc. It'll basically follow a semicircular path. So I guess let's start out with that and see if this even works. And then we can decide if we want to take it further. So let's see. So I want Cx to equal the halfway point. Okay, we can just write this in Elm code now. So the center of the circle, x, is going to equal x1 plus x2 all divided by 2. And cy is going to be the same thing, but with y. Then we should be able to calculate p0 now, assuming we have an arctangent function in Elm, which I'm not sure we do. Let's check. Oh, there it is. Okay, a cosine of Cx minus x1 I guess that should technically give two possible answers, but let's just take the one it gives us. Then, instead of this, now we'll calculate our x and y in a different way. So x is going to be Cx plus the cosine of p minus p0. And y is going to be cy plus the sine of p minus p0. And what's happening down here? The arrow, we probably did something wrong with floats. Oh yeah, the right side is expecting floats. Okay, so anywhere we're using x1, y1, okay, we need to two-float all this stuff. And we need to two-float this also. Okay, cool. Well, that compiles. Let's see what happens. Okay, that did not work at all. Let's see. Why don't we print this out for the moment? Debug.log. And I am wondering, let's see, this should all be in radians, right? Oh. So if p is in radians, interesting. I think we're missing, we need to like calculate the p final based on x2, I think. But let's debug this. All right. Oh, I guess we have the live debugger here. Oh, interesting. So it's actually moving. And I think we have a similar problem to what we had before, where everything was off by 1, and I wasn't sure why. So let's stick that back again and see if that improves things. Sort of. Oh, I know. The other thing that's wrong is the radius of this circle is not right. So we need to calculate the radius as well. And the radius, I think, for the moment, is just needs to be half of the distance between the 2 points. So that's going to be the square root of the difference x2 minus x1 squared plus y2 minus y1 squared all over 2. And then in here, the radius needs to be multiplied by that. So that means we're dividing all of these. And then we're multiplying it here. Okay, so the radius is going to equal the square root of x2 minus x1 squared plus y2 minus y1 squared, all divided by 2. And we also, I guess, need to float all of this stuff. Okay. Then here, we need to take this and divide by r. And then here we need to multiply by r. So the radius now is affecting things. Let's see. So it's first of all not starting in the right place. I guess it's like starting on the wrong side of the circle. Do we need to flip the direction of this or something? I don't know. I guess now I'm just kind of guessing. Ooh. That's interesting. Okay. So that's at least starting in the right place right now. And it also looks like it's following an arc that is going the right direction. So I think we just need to increase the speed, like p goes from 0 to 1, but we want the angle to go from whatever p0 is to halfway around the circle, which is pi over 2. Let's see if that works. Nope. What if we go all the way to pi? Oh yeah, sorry, it should be all the way to pi. I was getting things confused. Great. Well, that actually works. Oh, it didn't work with that piece for some reason. I think that's maybe a case where we're getting the wrong value of the arc cosine from what we want. Nice. Okay. Well, I was originally hoping to be able to have an arc that wasn't like a complete semicircle, have a shallower arc, but that math is going to be a bit more than I can handle for this late at night, and also we kind of have some weird things that I don't completely understand, so maybe we can revisit this in the future, but for tonight, I am going to leave this here. Thanks for tuning in, and tomorrow we will be doing our our regular ElmLive at 11:30. So I will see you then if you're tuning in for that. So have a great night.